Thanks for coming. If any of you have never heard about JSON, I've got a treat in store for you. I have been working at banks for quite a long time now. It feels a long time to me. Pretty much my whole career. Started 2008, just in time for the big recession. I've worked in many bits across banks, from risk systems, middle office automation, front office quoting, that sort of stuff. Finding myself actually going around in a circle now. I think I'm almost back where I started. I'm not sure I have to be pleased or sad about that, but lots of lessons learned along the way. I'll share a couple with you today. So, let's talk about LinkedIn. I'd stop there for copyright reasons. So yeah, resistance really is futile. It feels at this stage JSON is everywhere. And it's popular because it's cross-language, cross-platform. It's lightweight. It's human-readable, human-writable, and these are why we love it. It has all these great characteristics. But lots of other data formats can also claim these as well, or at least some of them. So what's the real secret to its popularity? Yeah. The lowest common denominator, the race to the bottom, is JavaScript. JSON stands for JavaScript Object Notation. And JavaScript is everywhere. And when it made the leap to the back end with Node, there was no going back. So JSON was proposed back in 2001. By someone called Douglas Crockford. And it was actually a workaround so that he could make a JavaScript object with the reserved keyword do as a key. And he couldn't do it, and he's frustrated. So his solution, very simple. I think we can all admire it. He just put it in quotes. And that's how JSON was born. What is JSON? Do I learn today in there? It has 6 basic data types.
Syntax error.
No.
Try to color.
Been doing too much TypeScript. Thank you. We've got null, number, string, boolean, object, and array. And this document here demonstrates all of them. And I was going to end my talk here, having delivered on my promise, but it turns out we can do more. And like I said, JSON is simple, as we saw. Just there's few moving parts. But because we're software developers, we've got to give ourselves a job. We need to make it do more, more features, more complexity. And comments were intentionally left out of JSON because Douglas Crockford didn't want them to be used as a passing directive, because the dream of JSON was to be portable. And if you have passing directives, that means you need implicit or inherent knowledge by the parser to understand what that thing might mean, which would couple your producer and your consumer together. So it was a noble goal, but it still doesn't stop us from wanting them. And anything outside the primitives I mentioned before, not supported. So there's lots that we want, that we use every day, especially dates and times. So the solution for those, just shove them in a string. And what we've now done is we've broken that portability, right? Because now we need to know how is that date or time encoded. I need to understand that to parse it back. A bit of an own goal there. So there have been, and continue to be, attempts to improve on JSON. There's things called CSON and HOCON and JSON-C and JSON-5 and Eden. Which never really took off. Or maybe they still will. There's still hope. But in the meantime, we're stuck with JSON. And JSON can be good. This is what we think of when someone says JSON. We would say this is a well-formed, valid document. Seems to represent... I've got another trading card there, haven't I, Harry? Seems to represent a person called John who lives in New York and has 2 children. Looks quite neat. But this is JSON too. And who says this isn't well-formed or valid? It conforms to the JSON spec. It can be parsed by a JSON parser. So what do we actually mean when we say a valid document? So there's a thing called JSON Schema, and it lets us specify constraints. And that's all there really is to it. So if the values in a JSON document fit inside those constraints, we say, according to that schema, this is a valid document. And conversely, if it doesn't fit, we can safely say, invalid document, throw it away. And I always think it's good to have validation like this at the edges of your system. Stops bad data getting in. If you know that bad data can't get in, you don't have to have guards everywhere saying, oh, if this is missing or if that's missing, or don't expect this format, without having them propagating all through your system, you can just say no bad data gets in. Here's about the briefest example of JSON schema I could fit in on a slide. So this is a schema for a JSON object, which has a type object, has 2 properties, product ID and product name. And the type field tells us what their JSON types are. Integer, string, respectively. And we can also express things like optionality. To say product ID is required in this document. The omission of product name means it's an optional key. And we also have metadata, what they're called annotations in JSON schema. And these let us give human descriptions and titles. And these actually perform the role that comments would. So let's convey intent and give extra information to the developer or to the end user. So the way you can use a JSON schema is by essentially giving it a document and saying, does this JSON document fit inside my JSON schema box? And there's a lot of third-party libraries that will do this for you, but the most frequently used one, I guess, is one called AJV. And it's as simple as saying, AJV, please validate this document against this schema. And this one, invalid, of course. I've given it an empty document. And it's telling me a few things here. The first part tells me that the document is missing the key product ID from the root of the document. And it's telling me that the required part of the schema is telling me that product ID is in fact not optional, but is required. And there's even a nice human-readable message at the bottom, which I can show to the user and help them understand what's gone right. So where else can JSON schema take us further? So numbers can be constrained to integers. And we can also say, actually, it's going to be a positive integer, but not more than 100. And for JavaScript developers, for whom number is kind of a fuzzy concept, it's pretty advanced stuff, I think you'll agree. And strings, like I mentioned before, the most abused of all data types. To remember, a valid JSON string is every permutation of every Unicode character. That's a lot of garbage. But JSON schema will let us constrain strings to something meaningful. Like at the top we have an enum describing a weather condition. We're saying only these 3 strings are allowed. We can say things like it has a format of a date, which is brilliant. Like, no more arguing about what date format we're going to use. That's been solved by the JSON spec. It has standards for dates, times, UIDs, email addresses, host names, IPv4 addresses. All this stuff which we may have floating around that we want to convey in a meaningful way, without just saying it's a string, like you deal with it on your own. We can specify the length of the string. The third example Dan says the string must be at least 8 characters long. And we can even specify that it matches a certain pattern. So think of something like a postcode or a zip code. So now we have a whole load of richer types in JSON. Without actually changing JSON, we've got an extra document that allows us to describe our JSON document. And it gives us all this good stuff without actually introducing more coupling between the consumer and the producer. And JSON schema can even represent conditionality. In this example here, we have an address in either the USA or Canada. And we can say, if the country is USA, then you need to provide a zip code which matches this zip code pattern. So JSON schema has a huge range of features like this. I've just introduced a few of them here, but there are many more. And in summary, I guess we have from it a much richer set of primitives that we've all been wanting. We have a way of providing comments. We can give default values for fields. And we can even represent quite complicated things by using the conditionality. We can compose schemas together with an any of, or an all of, or a one of. Suffice to say that regardless of how complicated your data structure, JSON schema probably has a way of representing that. And one area I've spent quite a lot of time in recently, the last few years, is in UI. And using a JSON schema document, there's enough metadata in there for you to produce quite good UIs generated from it. So the types obviously map onto a form input. UIs are for use by humans, so the titles, the descriptions are all very useful to show to them. We can validate fields as the user types, give some immediate feedback if they've typed something in wrong. And the goal is to have a UI which is easy to use, but also, or more importantly perhaps, helps the user capture data accurately the first time, because this is an entry point to the system, and if garbage goes in, it's going to come back out. And by having this schema be produced by the backend, you know that your UI is going to produce the right data for the backend to accept. So you already know that if you pass the front-end validation, it should be a successful API call to the backend. And once you have built a UI that's driven by JSON schema, it very quickly feels like hammer for every nail. If someone says, we need a new form to capture this bit of data, you could just say, no problem, give me the JSON schema, you drop it in, and there's your form. And JSON schema is also extensible. So you can add your own keywords, decorate your schema with your own keywords. Here the domain type, I'm saying it's a currency. And this means we can make a richer and more domain-specific UI. It does come with the cost of some coupling, because now I have to understand on my UI that this is a currency. But it's done in a progressive enhancement way, right? So if my UI doesn't understand what domain type means, at least I still know it's a string. I can show a string input. But it gives me the opportunity to make a much richer and more relevant experience. Especially in the case of currencies, think also stocks, other stuff like that, you're not going to really statically enumerate these inside your schemas. You kind of want to refer to them and source those things from somewhere else. So now you know the awesome power of JSON Schema. What are we going to build about? So it turns out you can build a structured products platform with a generated UI. And if you don't know what a structured product is, I'm going to give you an idiot's guide. I'm an idiot. You're getting the guide. They come in 4 main flavors, which cater for different risk and reward appetites. The main idea, I think, is they offer a better return than bonds, but they don't have as much risk as stocks. And the way they achieve that is mixing the two things together, really. This one here, the text might be quite small, but we have a bond, the light blue bit, and an option, which is the dark blue bit. The bond gives you protection on the capital. The option gives you the upside of the underlying asset. And the payoff profile of the product, which is what it's worth compared to how much the underlying is worth, can have interesting features. For very simple financial instruments, this would be a straight line. But here you can see in the steep bit of the graph, that's saying that the underlying, that this product performs twice as good as the underlying, up until you hit the cap at 15%. And we can also look at the downside in the negative region of the graph and see that it doesn't protect our losses. We get all of the downside as the investor. So this sort of thing is good if you think, I expect the underlying to go up, but maybe by not very much. This product would double your returns. I'm not a financial advisor. Don't invest. So I like to think of structured products as a bit like Megazord. They're composed of many parts, each with their own behaviors and strengths. They combine to create something more powerful than the sum of its parts. And they can save the Earth.
It's the fabulous.
So let's go back to JSON Schema and talk about why we might want to model structured products this way. So we have all these different features from various financial instruments which we can combine together and make something better, like a Megazord. And there's loads of permutations, and probably some are a bit rubbish, but lots of them are very attractive to buyers. And as the market moves and you have bull markets and bear markets, different products become more popular. So we can stick a particular combination together, give it a fancy name, and now we have a new structured product. And yes, they are complicated, very complicated, but they can still be modeled by composing JSON schemas. Especially if we use, all those tools in the box, the composition, the conditionality. But what we end up doing actually is modeling the features themselves. Features like the upside and the downside and barriers and things like that, rather than the product itself. And that's important because if we can model all those features, then we can model all the products, even ones that haven't been invented yet, if they're just a different composition of those same features we already support. Which is is often one of the things that the business expect from us as IT. They say, what do you mean? It's going to take 3 months development time to add this new product. It's just like that one we support over there. And it feels a bit rubbish to say, yeah, sorry, we've got to copy all these flags and do all this stuff. And really, it's the same bits glued together in a different way. So what happens if we start from a schema and we build from there? Firstly, it's a good exercise in domain modeling. Like whoever really sits down and says, what are we building here? How do we describe it? And the schema is first class. It's there for everyone to see and inspect. It's just a data document. You don't have to drag it out of a class model or something that it doesn't want to come out of. loads of tools for comprehension. It's a standard. People are building around this thing. As I mentioned, it can be used in any language, any application. And it's something that we might often do as a side effect. Like we might build a model of something, and we might expose that model as part of our API in a Swagger or Open API spec. It feels like an afterthought. We could put this front and center and say, this is what we are building around. And even having done all that, even if we model that in our own application, what's to say that the next application that we talk to hasn't modeled it slightly differently? So a structured products platform is a big, complicated system. Lots of applications, lots of people in different roles, like business users, quants, developers. Some of whom know a lot about structured products and the bits that put them together, and some people, like me, don't understand very much. Shouldn't have to understand very much, really, when the expertise is already there within the organization. So we can put the schema in the middle of the system, which describes this complicated thing. And then the applications around it can really treat it as a blob. And if we need to know what something is, we can use the schema and refer to it. But it means that every application then doesn't have to have its own representation of this thing that's shared across them. It means we don't have entire layers of mappings around applications just to translate something from application A to application B to application C when they should all be working in the same domain. It means that new products can be released in the schema without huge upheaval across the entire system. The applications themselves can be built with different technologies. And we can write tests using these schemas, knowing that they accurately represent the data that we expect to be moving around between these applications. So I think of it as a bit like an ant colony, or a megazord. The colony itself works at higher abstractions and models threats and opportunities in the world around it. But the individual ants are simple automatons, just working on their given job. But nevertheless, they can pass signals to other types of ants. They don't have to know what the signal means. And they don't understand what the colony is doing, but they know what they're doing, and the colony relies on them to do that role. The analogy here is that we can make applications more like ants, simpler, easier to understand, easier to test. And they and their developers don't actually need to know so much about the domain, in this case the structured product, to do their job, but the system itself is giving these system level features that the business wants. So as I mentioned, my particular experience is building UIs. And one immediate thought you might have said when I said generated UIs and showed you the rather rubbish example is that how can you make a UI that's actually any good? So what we did was we built a pipeline to take these schemas and progressively enhance them to get them to a point where they're suitable to render into a UI that had a good user experience. So we do things like apply defaults. If there's a default value available, we don't need a user to type that in. These would be based on who you are, what your role was, things like that. If there's an enum with only one choice, we can hide that. The user doesn't have to do anything there. We can hide read-only fields. Again, the user can't interact with them. And we can rename fields with localized terminology so that the UI is speaking the language of the user. And we can order fields so that fields that should go together appear together. And we end up with an enhanced schema which describes a form which is both concise and relevant to the user. And then we built a kind of state machine in the front end using the schema and a JSON document. So the schema tells us some defaults. We could build the first version of the document. And then we use the two things to render a form on the screen. The user interacts with that, supplies us with a new value. We push it into the document. we run it through the validation, and then we have produced the next version of the document, and we render that on screen, and the user interacts with it. And so we have a responsive and helpful UI that helps enable accurate data capture, which is the entire point of a for. So building a bespoke UI is not easy for complex things like structured products. Building a generated one isn't either, but in many ways, JSON Schema did actually make this whole task quite a lot easier. So now we had our state machine for producing data for rendering. The renderer didn't actually have much to do. It had to choose the right component for each field type that it came across. And we had a mix of primitive and progressively enhanced components. If there was a new thing we didn't understand, we could always fall back to the primitive. But rendering essentially then becomes a pure function of the machine state, and it outputs HTML. That means we could relatively cheaply have multiple renderers depending on the use case. So on the left we have what we call the card view, slightly more verbose one that took up more of the screen, and on the right we have a grid view, which shows structured products side by side so you can compare them. And we were able to do this because we pushed all our logic down into a kind of more data layer that we could test more easily as well. Didn't have to interact with the DOM to write our tests on the correct behavior for that. All of which is a very long way of saying you can make first-class models of your domain, sit down with your business people and do that. And then applications and developers can use that to build the system of more simple applications. It turns out JSON Schema has enough features for you to be able to do this. And we can even generate good UIs for capturing data to feed into the system. Thank you all for listening.